Jiao how's everyone today? Good? So, just remember, you're required to take two types of notes. You have to use a video and read the book or some kind of notes you have to do on your own time. So this is to help you out. So, take a look. Today I'm going to show you how to graph simple rational functions. Awesome. So what's a rational function? Rational basically is just a fraction. So we're going to learn how to graph fractions today. Awesome. Excited? I am too. Let's take a look. So this is what a simple rational function looks like. Y equals 1 over x. How do you graph this? There's couple things we need to talk about. First of all, you need to know how to find the domain and the range. This is important because it's going to tell you where the asymptotes are. So domain and range. So what's domain? Remember, it's the x value, the values you could put in. Usually when you check domain and range, I like to check these. I like to check positive numbers, I like to check 0, and I like to check negative numbers. These are x values. So if I put in a positive numbers, does it work? If I put in 2 for x, that becomes y equals 1 over 2. That still works. Put on 3, 4, 5. Positive numbers work. Negative numbers, do they work? If it was negative 2, 1 over negative 2 is negative 1/2. Still works. If I put in 0, does it work? No. So therefore, because you can't divide by 0, if you're actually doing your calculator, you go 1 divided by 0 in calculator, your calculator would go error or domain error or don't do that. That's not right. Right? So, what's the domain here? Domain is actually all numbers work except x cannot be 0. Sound good? Range. What comes out? Every number comes out, right? If I say I want 2 to come out, I just need the denominator to be 1/2. If I want 1/3 to come out, I just need the denominator to be 3. If I want what comes out? Well, all numbers except 1. There is no way that you could get the y to be 0. No way. Think about any x you put in there. Will y ever be 0? Can you think of an x that will give you y 0? So remember, domain's the input. What comes in, you could put in any number except x cannot put in 0. And range is what comes out. What comes out after you put in your number? Everything, every number would come out. Except never ever will you have a range of 0 in this fraction. Does that kind of make sense? These are important because this determines the asymptote. What are asymptotes again? Asymptotes are lines they don't cross. Those are lines that the impossibility lines. Borders, things that you cannot be. It cannot be x is 0, it cannot be y is 0. Does that kind of make sense? So let's graph this. First of all, I need to graph my asymptote. My asymptotes are x equals 0, y equals 0. These are lines where the values cannot be. So I draw those lines to make sure I don't cross those lines. Sound good? I'm going to draw the first one in green. X cannot be 0 looks like this. This is called the asymptote. Never cross. Then the second one I'm going to draw in blue. This is the other asymptote. Y is 0. So the graph is going to be in here. The graph will not touch any of these. So what the heck does this graph look like? If you don't know what the graph looks like, what you can do is just start plugging in numbers. Now, I look at this and go, I can't just plug in random numbers. The graph is divided. This green line right here, the graph will never go to. So I know that the graph will be on the right of the green line and the left of the green line. Does that kind of make sense? So when I'm graphing, I want to pick numbers to the right of it and see what the graph looks like, and I want to pick numbers to the left of it and see what the graph looks like. Because this is a wall. The graph will not go over the wall, right? It's like a border. So I want to see what it does on the right of the border and what it does on the left of the border. So I'm going to pick numbers on the right. So since it's at 0, I'm going to pick 1, 2, and 3. And I want to pick something close to the border because I want to see when it goes closer to the border, what does the graph do? Right? So I'm going to pick 0.5. This is going to give me right of the border. I'm going to plug it in. Y equals 1 over 0.5. Y will give me, good, 2. Take your time, plug in the rest, see what you got. Pause the video. Alright, unpause it when you're done. This should give me 1. This should give me 1/2. This should give me 1/3. So I'm looking at this, and I'm going to graph this. It looks like I have 0.5, I have at 2. 1, I have at 1. 2, I got at 1/2, and I got at 1/3. So you can kind of see it mapping out now. So it looks like a graph. It's not going to cross the blue line. It's not going to cross the green line. Right? Those are borders. It's like a car driving. It sees a wall. It's not going to run into the wall. It's going to curve away. So this is what your graph looks like. It goes down like this, and then it sees the wall and curves away from the wall. That's what it looks like. Is that straight? Yes, it is. Don't judge. Perfecto. Alright. That gives us the right side. So that's what's happening on that side. So what's happening on the other side? Let's plug in numbers. Let's plug in numbers on the left side of the wall. What numbers would you plug in? Same ones, right? But on the left side, I want to plug in -1, -2, -3, and one close to the wall, -0.5, to see as they're going close to the wall, where is it churning? Pause the video, plug it in, see if you got that. Then check your work with my work. I got -2, -2, -1, -1/2, and -1/3. Did you get the same thing? Good job. If not, that's okay. We're going to do some more practice, and you're going to practice inside of class. Let's graph this. I got -0.5, -2, 1, -1, 1/2, and 1/3. You see that? So let's see. It's going right there, and then sees a wall, it curves away. So it goes like this, curves, and goes down. And this is what your graph looks like, right? This is what a graph of a rational function looks like. Sound good? It's two asymptotes curving on one side and then curve on the other side. All right, let's do one more. Try to do this on your own, right? First of all, first thing you need to do is find the asymptotes. There's 2 of them, and it has to do with domain and range. What can't I put in and what won't come out. Sound good? All right, pause it and then check your work with me. My asymptote. My first one is x equals 3. My second one is y equals 0. Sound good? Let's double check if you got that right. If you don't understand, take a look. This is how I got that. I know the denominator can't be 0. So what number in there would give me 0? Well, 3, because 3 minus 3 is 0, and 2 divided by 0 is undefined. Once again, or I could do this. X minus 3 cannot be 0, therefore x cannot be 3, therefore that's an asymptote. Because x cannot be that, therefore we have to draw a line telling us that's a border. We cannot cross it, we cannot touch it. Clear? Why? What doesn't come out? Well, it's the same thing. In this fraction, I can never get out a 0. Does that kind of make sense? All right. Now, first thing we draw our asymptotes. My first asymptote at x equals 3. My second asymptote at y equals 0. Once again, I'm going to graph this. I'm going to plug in my numbers, make a t-table. I'm going to pick numbers to the right of it and numbers up to the left of my border. To the right of my border, pause, see if you get the same numbers I got. I got 3.5, I got 4, I got 5. If you need more numbers, plug in more numbers. Always be sure before you graph it. On the left, I got 2.5, I got 1. Oh, just kidding. I got 2, I got 1. And if you want, you can do more. Let's plug them in. Pause the video, see if you can plug in yourself, see if you get the same answer, then unpause and check your work with what I'm doing. Alright, 3.5, that would give me 3.5 minus 3. That would be 2 over 0.5, which is 2 over 1/2, which is 4. Continue on. I plug in 4, gives me 1, gives me 2. Plug in 5, gives me 2, gives me 1. Alright, I'm going to do another one because I'm not comfortable with that. As I start plotting this, at 3.5, 1, 2, 3, 4, 4, 2, 5, 1, I kind of can see where it's going. But just to be sure, why not check, right? Especially on a test. on your homework, if you're not sure, what's the harm of doing one more number? Let's do one more number, 6. That would be y equals 2 over 6 minus 3, which is 2 over 3, which is 2/3. Which is 6 and 2/3 right here. So I can see the graph a little bit better. I can see it coming down like this. I can see it curving and going to the right like that. Going toward the asymptote, closer, but never touching and never crossing. Clear? Let's go to the other side. I plug in my numbers. I plug in 2.5. I get -4. I get -2, -1. Sound good? I'm still not comfortable. I'm going to try another number. Let's try 0. Okay? Don't think it's symmetric or anything like that. You know, plug in your numbers correctly. Do your work properly. Put in 0 is -3, -2/3. Right? It's only symmetric in this case, but we're going to do another one where it's not. It's not really symmetric because the numbers don't match. One's positive, one's negative. Just talking out loud. All right, 2.5, 1, 2, 3, 4. 2, -2, 1, -1, and 0, 2/3. Sound good? And I see my curve there. It comes from the line, sees the wall, curves away from the wall, and therefore it's my graph. Ta-da! And then in your book, it should ask you, what are the asymptotes? The asymptote is x equals 3, x equals 0. How do you feel? Good? Let's do one more example and call it a day. Last example. Graph this. Try to do it by yourself. Right? See what you can do. First things first, find the asymptotes. Pause the video, try it yourself. I know some of you are not pausing the video, like Michael, but do it, Michael. I'm watching you. So first one, x equals -2. Asymptote for y. Y equals 1. Woo! How did I get that? Well, take a look. This one will never give me 0. 0 plus 1 will never give me 1. Does that make sense? A little bit? Let's graph this. Everyone make your t-table. Before you make your t-table, let's draw in our asymptotes. X equals -2 right here. And y equals 1 right here. Alright. Let's make our t-table. Pick our numbers. Remember, pick to the right, pick to the left. Pick your numbers, pause the video, double check, see if you got the same numbers I got. I got -1.5, -1, 0, and one more for safekeeping. Alright, other side, I got -2.5, -3, -4, -5. Just looking at the next numbers down the line. Let's plug these in. Pause the video, try it yourself. I'm going to plug in one for you, and then I'll do the rest in my head for time's sake. Y equals -1 over -1.5 plus 2 plus 1. This will be -1 over 0.5 plus 1. That will be -2 plus 1, which is -1. Sound good? Plug in -1. That will be -1 over 1 plus 1, which will be -1 plus 1, which is 0. Plug in 0. That will be -1/2 plus 1 is 0.5. And plug in 1. That will be 1/3 plus 1. That will be 0.67. Is that right? Yeah. Or 2/3. All right, let's graph that. Let's graph that. -1.5, -1. Oh, sorry, -1 down there. Hehe. Man, that eraser's big. -1, 0, 0.5, and then 0.67. Something's wrong, but let me double check that. So you see your curve there? 1/3 plus 1, 0.67. Okay, sounds good. Alright, plug in your next number. -2.5. How much time I have? Oh, running out of time. Alright, so I ran out of time. But plug in your next number and you should get something like this. and then you should get your other curve.